Hi, my name is Saket from A section AIML. My topic in computer networks is in network intelligence control towards self-driving networking architecture. Let's go to the first slide. A network intelligence control towards a self-driving networking architecture. The world is increasingly reliant on networks, with everything from our daily communication to critical infrastructure opening on complex interconnected systems. However, traditional networking approaches are often static, inflexible, and struggle to adapt to the dynamic demands of modern applications. This is where a network intelligence control comes in, offering a paradigm shift towards self driving, adaptive, and autonomous networks. INIC envision a feature and where networks can automatically learn, adapt, and optimize themselves, responding to real time conditions and evolving user needs. This presentation will explore the key principles, challenges, and the potential benefits of INIC, outlining its journey towards a self driving computer architecture. Basically, it's a networking architecture. Let's go to the third slide. Now, let's see the introduction. The needs for adaptive and autonomous networking. Modern networks face growing complexity with ever increasing demands for diverse applications and a rapidly expanding number of connected devices. Traditional networking approaches rely heavily on manual configuration, which is time consuming, error error prone, and often inadequate in handling dynamic changes in network traffic patterns. The need for adaptive and autonomous networking solutions has become increasingly urgent to address the limitations of these manual methods. In network intelligence, Control INIC aims to empower networks with the ability to learn, adapt, and self optimize in real time. Transforming them from passive infrastructure to intelligent and reactive entities. There are dynamic traffic patterns, diverse application requirements, rapid network expansions, evolving security threats. The rise of cloud computing, video streaming, and mobile gaming has led to unpredictable and bursty traffic patterns, challenging traditional network management strategies. Di- Different applications have varying latency, bandwidth, and security needs, demanding flexible and adaptable network resources. The ever growing number of connected devices and the emergence of new technologies such as IoT and 5G requires networks to scale seamlessly and efficiently. The ever growing number of connected devices and emergence of new technologies such as IoT 5G requires networks to scale seamlessly and efficiently. Cyber attacks and data breaches are becoming more sophisticated, demanding proactive security mechanisms and real time threat detections. Limitations of traditional networking approaches. Traditional networking approaches are often categorized by centralized control, static configuration, and reactive problem solving. These limitations pose significant challenges in managing modern, dynamic, and complex networks. Centralized control can become a bottleneck under high traffic loads, leading to latency and performance issues. Static configurations fail to adapt to changing network conditions, and user needs. Reactive problem solving often results in delayed responses and inefficient resources utilized. These limitations highlights the need for a more intelligent and autonomous approach to network management, leading to the development of INIC. Centralized control, static configuration, reactive problem solving. Decisions are made by a single entity, potentially creating a bottleneck and delay response. Networks setting are fixed and require manual adjustment, failing to adapt to dynamic changes. Reactive problem solving. Issues are addressed after they occur, leading to delay and potential service disruptions. Principles of in-network intelligence control. INIC aims to address the limitations of traditional networking approaches by leveraging the power of artificial intelligence and distributed computing. It empowers networks with intelligence autonomy, enabling them to adapt and optimize themselves in real time. INIC core principles revolve around decentralized decision making, adaptive resource allocation, real time monitoring, and self healing capability. These principles enable networks to become more resilient, and responsive to dynamic demands. Decentralized decision making, adaptive resource allocation, real time monitoring, and anomaly detection, self healing, and self optimization capabilities. Network can automatically identify and address issues, optimize performance, and adapt to change conditions without human interaction. Network resources are dynamically allocated on current traffic patterns and applications requirement, optimizing performance and utilization. decentralized decision making and contributed control. INIC adopts a decentralized approach to decision making, empowering network nodes to make local decisions based on their own observation and real time conditions. The distributed control model eliminates the bottleneck associated with centralized control, allowing for faster response to dynamic changes in network traffic instead of relying on single central authority. As we can see, there are 3 points: real time data collection, local decision making, and distributed control. Each network node gathers local data about traffic patterns. Nodes use AI algorithm to analyze data, and decisions are coordinated across the network, ensuring optimal resolution, utilization, and performance. These are adaptive resources allocation and load balancing. Real time monitoring, anomaly detection like network traffic monitoring, security threat detection, performance metric analysis, and resolution resource utilization monitoring. Self healing and self optimization capabilities like anomaly detection, issue identification, self healing mechanism, self optimization. Use cases and application scenario like data center optimization, wireless network optimization, smart city infrastructure, and cloud computing infrastructure. Challenges and future directions are like AI algorithm development, data privacy and security, network interoperability, and network complexity. So hope you like it. Thank you.